Now in this video, we're going to differentiate this function, square root of x, from the first principle. Good. And differentiating a function from the first principle, we make use of this tool. We take the limit as h tends to 0 of f of x plus h minus f of x divided by h. Good. And when we take that limit as h tends to 0, it will give us another function, right? And then we call that the derivative of that function, y with respect to x. So in this case, I'm going to say f of x is the same thing as y, right? So that when we differentiate it, we're just going to apply this limit. Good. Okay, so let's see what we got. In this tool, to make use of this tool, we will need to get f of x. Of course, f of x is given from the question, right, to be square root of x. And then secondly, we will need f of x plus h, just from the function, all right? Now, f of x plus h, let's see what we'll get. Since f of x is the square root of x, then f of x plus h will be the square root of x plus h, all right? That's just by replacing x with x plus h. You are replacing. So, you just put x plus h in here, all right? Good. And now that we have f of x plus h, and then we have f of x, we can now take the difference, all right? And then this denominator, we just need to put down the h, just as a matter of notation. Okay, good. And then we can now talk about the limit as h tends to 0. So let's just do that over here. We have the limit as h tends to 0 of f of x plus h is the same thing as square root of x plus h. Then minus f of x is the same thing as square root of x, right? And then we divide everything there by h. Good. And now that we have a fraction there, okay, as h tends to 0, assuming we want to evaluate this limit by substitution, we will see that as h tends to 0, we will plug in 0, just substitute 0 straight, and so what we'll get, you will see that we're going to have square root of x minus square root of x. Now becomes 0. Then we can put 0 for h here. We'll have 0 over 0 situation. So we do not just evaluate it like that, since this is giving us an indeterminate form. So what we need to do here is to go ahead and try to rewrite this function, all right, a little bit, and then we take the limit as h tends to 0. Good. So what I would like to do is to multiply the numerator and denominator of that function by the conjugate of the numerator of the function, all right? So let me put it down for you. The limit, okay, we continue. This is the limit as h tends to 0 of, let me put down the original fractions, right? Minus the square root of x, all divided by h. So I said I'm going to multiply the numerator. I'm going to multiply this numerator by the conjugate of the numerator. That is just, I'm going to change this sign, all right, to addition. So we're going to have square root of x plus h plus, this is minus, so we're going to use addition, then the square root of x, right? That is just the conjugate of the numerator. So we are going to multiply that to the top and the bottom. So I'm going to multiply the same thing here, x plus h plus square root of x. Good. That is just what we mean by multiplication by 1. All right. And now, let's see what we've got. We're going to have to expand the numerator, right? And then we will not touch the denominator, but we just have to expand the numerator. When we expand that, we're going to enter with the limit as h tends to 0 or something, all right? So to expand that, you are going to have to split. You push this one, right? Multiply it with this, and then multiply this same thing with this one, and then do the same thing with this, all right? Remembering the negative sign. When you do that, you are going to add the results together. You will enter with the square root of this times the square root of that. That will give us just x plus h. That is square root times square root will give us the square root squared, which will cancel out, right? We're left with x plus h. And then we are going to multiply this and that. We're going to have negative x. All right, that is what I get when I multiply, expand the numerator. You can go ahead and check that out. And then the denominator, we just keep it as h times the square root of x plus h. And then we add it with square root of x. All right, good. Let's see what we've got. In the numerator, we have x, right? and then minus x, that's going to become 0. And we're just left with h at the top, right? So I'm going to take the limit as h tends to 0. Always remember to put these down. Okay, this notation. And then we have h here. Since the x's will just get to 0, or will just become 0, over h times the square root of x plus h plus the square root of x. Good. And now you see that this h and this h will cancel out, all right, leaving us with the limit as h tends to 0 of 1 divided by square root of x plus h, then plus the square root of x. Good. That is very nice. That is, this h and this h cancels, and we have this, right? Okay. So you take note of where we are. Now, we can now do the substitution since we've rewritten the function. So our work was just to rewrite this function, and I've rewritten it by multiplying the function by 1. 1 in that the numerator I multiplied with and the denominator here, they are the same. So they can just give us 1. That's very nice. Okay, so from here we can move from here to this point, and then I substitute h. As h tends to 0, we will have, you know, this is the limit of the quotient. The limit of 1, as h tends to 0, we'll just have 1, right? Because 1 is just a constant. It is independent of h. Then we come to the denominator. As h tends to 0, we'll have square root of x plus 0. That is square root of x, right? Because x is approaching 0, we can just plug in 0, as I said, by substitution. Then we add it with, well, here, this is independent of h, so nothing will affect it, all right? Good. And now at the top, we have 1. And then the bottom, we have square root of x plus square root of x. That is 2 times square root of x, right? There are 2 of them there. And this right here is the derivative of y with respect to x. Okay, great. All right. Thanks for watching. Please subscribe to my channel.